Hello everyone. For this tutorial video, I like to explain how capacitors behave with AC signals, similar to how I explained how inductors behaved before I explained how to analyze them in situations in combination with resistors. If we remember from first learning how capacitors work, we know they oppose changes in their voltage, just like an inductor opposes changes in its current. So this means the current across a capacitor is the capacitance times the change of voltage over the change in time. So this logically means the current is behind the voltage now, unlike in an inductor where the voltage is behind the current. But the general graph patterns are still the same, namely that when the voltage is at a maximum or minimum, the current is exactly zero, and when the voltage is changing as fast as possible, the current is at a maximum, or minimum if the rate of change is negative. And also, like with simple inductor circuits, the power wave looks like this. It means the same thing conceptually as in the inductor circuit, namely that the total power dissipated is zero, because it repeatedly takes on and gives back energy to the circuit. However, the similarities to inductors end here because, as we can see, the more frequently the AC signal changes, the more conductive or less resistive the capacitor will be, whereas the opposite was true for inductors. So X sub C is 1 over 2 pi frequency times capacitance. And then for a simple circuit like this, we would simply use Ohm's law to figure out the current and voltage, just like for a simple inductor circuit. Although we would obviously pay attention to the phase difference between the voltage and the current. In my next tutorial video, I like to talk about how to analyze circuits with a resistor and capacitor in series, and then after that, a resistor and capacitor in parallel. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.